Module 2.1. As a reminder, it's recommended to print the video script and annotate the script while watching the video for later use. Video scripts are available on Canvas. Module 2.1. What is the difference between a population and a sample? We'll begin by discussing why the field of biostatistics is applicable to you. As a society, the amount of data we produce is increasing at a rapid rate. Decisions that impact your everyday life are being made based on the analysis of data. Everyone needs a basic understanding of data analysis to be able to navigate the increasing amount of information that is available. Most students enter a statistics course thinking that they are taking a math course, but this is not the case. Statistics is much more than the application of formulas. According to H.G. Wells, statistical thinking will one day be as necessary for efficient citizenship as the ability to read or write. According to Florence Nightingale, statistics is the most important science in the whole world, for upon it depends the practical application of every other science and of every art, the one science essential to all political and social administration, all education, all organization based upon experience, for it only gives the result of our experience. You may be asking yourself, what is the difference between statistics and biostatistics? Biostatistics are the development and application of statistical methods to a wide range of topics in biology. It encompasses the design of biological experiments, the collection and analysis of data from those experiments, and the interpretation of the results. In this course, you will learn the fundamentals of statistics, and we will apply them to biological data. Three of the primary goals of this course are to provide a set of tools to understand data analysis, communicate data analysis, and the ability to critique the analyses of others. The majority of people will never analyze a set of data on their own, but they will rely on the conclusions of others to learn about the world around them. The ability to critically think about presented information is a vital tool. One of the biggest mistakes that introductory biostatistics students make is thinking that statistics is a mathematics course. While it is true that statistics courses implement mathematical tools, it is very different from a mathematics course. According to the famous statistician John Tukey, statistics is a science, not a branch of mathematics, but it uses mathematical models as essential tools. The field of statistics has its own language with the goal of being able to say something meaningful given a set of data. As we move through the course, you want to focus on the meaning behind the numbers and what they mean in a broader context, not just the formula used to derive the numbers. After this video, visit the website listed here for a helpful discussion of why learning statistics is important and why you don't need to be a math major to do well in a statistics course. How can biostatistics help us learn about an unobtainable group? Researchers are often interested in learning about a group of people or things. The group they would like to learn about is known as the population. Unfortunately, collecting data from every unit in a population can be difficult, if not impossible, task. Instead, researchers will select a subgroup from the population to examine. This small group is known as a sample. Listed here are 6 important definitions. Pause the video at this point and make sure to read over these definitions. Once you're finished, restart the video and we'll look at an example of all 6 of these. To illustrate the difference between the 6 definitions, we'll look at an example. Suppose I'm an ant. Yes, I said ant and not aunt. As a matter of fact, I'm the queen ant. Lately, I've noticed that my worker ants have been acting somewhat discontent with their jobs. I decide that I want to find out about job satisfaction in my hill. There are so many ants in my hill that it would be an impossible task for me to ask all of them if they are discontent. So instead, I ask 200 ants how they feel. find that 99% of them are dissatisfied and would prefer to spend their time eating at the picnic rather than carrying food back to me. Notice in this example the variable is job satisfaction. The subjects, or units, are the individual ants in the hill that I spoke with. The population is all of the ants in the ant hill. The sample is the 200 ants surveyed. The parameter is the percent of the entire ant hill that is dissatisfied. This exact number is impossible to know since I cannot ask all of the ants. In other words, I cannot speak to the whole population. The statistic is the 99% of the 200 surveyed ants that are dissatisfied. How can biostatistics help us learn about an unobtainable group? The field of biostatistics is really the study of variability. If every subject in a study that was exactly the same and reacted the same way, the practice of statistics would be boring. Luckily, subjects or people are different from one another, and we need biostatistics to provide strategies. Your turn. Read the following examples and identify the population, sample, parameter, and statistic. The first part is worked for you. I want to know how American voters will vote in the next upcoming election. In particular, I'm interested in the percentage that will vote Republican. I distributed an online poll and received 550 responses. 52% of the respondents would vote Republican at the time of the survey. So notice here, I'm interested in learning about all American voters. So the population is American voters. The sample are those that I was able to collect data from. In other words, the sample is the 550 respondents. The parameter is the percentage of all American voters that will vote Republican. And the statistic is the 52%. The statistic, the 52%, is the percentage of the respondents that will vote Republican. Or in other words, the percentage of the sample. Take a moment, pause the video, and answer the next 3 questions. When you come back, we'll look at the answers together. I want to know how many people in Fayette County, Kentucky recycle. I interviewed those people living in the zip code 40505. 74% of them recycle. Notice here the population would be all residents of Fayette County, Kentucky. The sample is the residents of the zip code 40505. The parameter would be the percent of all Fayette County residents who recycle, whereas the statistic is the 74% is the percentage of the sampled residents from the zip code 40505 that recycle. I work at Yankee Candle Company. I want to know what the average amount of wax in each candle is. I take a random sample of 300 candles, and I find the average amount of wax in the 300 candles is 32 ounces. Notice here the population is all candles produced by Yankee Candle Company. The sample is the 300 randomly selected candles. The parameter is the average amount of wax in all the candles produced by Yankee Candle Company. And the statistic is identified as the 32 ounces is the average amount of wax in the 300 sampled candles. I love to eat M&Ms, and my favorite color is red. I want to know the average number of red M&Ms in a large bag. I take a random sample of 210 large bags of M&Ms. I find that the average number of red M&Ms in a large bag is 80.7. Here, the population is all large bags of M&Ms. The sample is the 210 randomly selected large bags of M&Ms, and the parameter is the average number of red M&Ms in all large bags. 88.7 is the average number of red M&Ms in the 210 sampled large bags of M&Ms, and this is the statistic. To finish this note set are a couple critical thinking questions. Can you give 2 reasons why taking a sample is necessary? Also, ideally when we pick a sample, we want it to reflect the characteristics of the population. Do you think that a sample will always have the characteristics that are similar to the population the sample was selected from? Why or why not? Pause the video here and think about these 2 questions. When you come back, we'll look at some answers. Question A asks to give 2 reasons why taking a sample is necessary. Some potential answers are given here. Inspecting a population can be expensive and it may take a long time. Further, the sampling process may even be destructive. For example, car manufacturers will sometimes take a sample of cars and perform a series of crash tests to determine if the cars are safe. Using all the cars would be impractical because it's expensive, would take a long time, and more importantly, the process is destructive. Question B asks, ideally when we pick a sample, we want it to reflect characteristics of the population. Do you think a sample will always have characteristics that are similar to the population the sample was selected from? No, not all samples are representative of the population. A sample could include too many individuals from one subgroup of a population and exclude individuals from another subgroup of the population. For example, if you only ask your friends to fill out a political survey, their views are likely to align with yours, and you will not see the opinions of other people who are not in your friend group. This ends the Module 2.1 video.